Hi, everybody. Welcome to the Windows Command Line and Windows Terminal and WSL2 session for Build 2020. My name is Kayla Cinnamon, and I am the Program Manager on Windows Terminal.
And my name is Craig Lone. I'm the Program Manager on the Windows Subsystem for Linux, or WSL.
So we're going to cover what's new with both Windows Terminal and WSL today at Build. So the first thing I will talk about is Windows Terminal and what our large announcements are. So I'm happy to announce Windows Terminal 1.0 is finally here and what our large announcements are. For about a year now, we've been open source and working with the community to make sure we can get a proper 1.0 build. And we're here to announce it today that it is readily available and you can download it from the Microsoft Store. So what comes with 1.0? Well, you can optimize your workflows with both tabs and panes. So you can run any command line application in tabs or within multiple panes inside a tab. You can also run it in 10 different languages. So if you are familiar with a different language aside from English, we have localized it in 10 different languages. And since we've localized it, we also have a modern text rendering engine, and it will render both Unicode and UTF-8 characters. So you can have emoji as well as all those languages that you like to use. It's also fully customizable, so you can have different themes, color schemes, fonts, background images. The possibilities are unlimited, and you can have that all within Windows Terminal. And of course, it's open source. So we've been working with the community the whole time, and I'll show you some features that have been contributed by community members, as well as things we've worked on open source on GitHub. And one last large announcement we have is that we have a docs.microsoft.com site, and it's basically a full manual of how you can use Terminal. So if you have any questions about what you can do with it, how you can run different shells in there, what customizations you can find all the answers on the docs site, and that's at ak.ms/terminal-docs. So with that, I want to jump into a demo and show you what comes with 1.0 for Windows Terminal. So one question that we get often is, why did you make a new terminal? So I want to show you what comes shipped in box today and explain why we did branch off and create a new Windows terminal. So if I open Command Prompt and PowerShell, you'll notice that these boxes look very similar. And that's because the application that is running the shells inside of them is the same. And I can prove that to you by opening both of the properties menus of each one and showing that they're identical. So the application's the same. So a lot of people have asked for new features to this experience, such as tabs, panes, background colors, background images, more fonts, emoji support, everything like that. But due to backward compatibility reasons, we can't make too many changes to this experience. So that's why we made the new Windows Terminal. So I will now show you what Windows Terminal 1.0 looks like today. So if I open Windows Terminal here on my machine, this is my Windows Terminal setup. I have done a few customizations. I am running Powerline here in my prompt, and I was able to get those glyphs to show up by changing the font to a Powerline font. And I'm running PowerShell 7 as my default profile. I can open a new tab of PowerShell by typing Control-Shift-T, and that'll open my default profile. I can also do the same by clicking the plus button, and it will open more tabs that way as well. If I want to open a different profile, I can go into the dropdown, and I have a ton of different ones here. I have the Command Prompt and Windows PowerShell that come in box and Windows. I also have 4 different Windows Subsystem for Linux distributions, and those were dynamically generated by the terminal, and I'll show you how those come in and how you can manipulate those. And then I also have Azure Cloud Shell, which comes shipped with Windows Terminal. So I want to talk about how you can customize this experience, because this is not too customized, and I want to walk you through how you can make your Windows Terminal look exactly how you want. So if I open the settings, this will open a JSON file, and it opened in my default JSON text editor, which is VS Code. So this is the same setting where if you are in Windows and it asks what application would you like to open for this file type, that's where you set VS Code for JSON files. So I like to use VS Code because it has the JSON schema already included, which will help me fill out this JSON file. And a lot of people have asked, why is it a JSON file? Where's the settings UI? We decided to go with a JSON file because it's easily portable. So you can have your settings on one machine and then transport it to another machine very easily. Or if you're in an enterprise and everyone needs to have the same experience, you can create one settings.json file and distribute it to everybody. So that's why we went JSON. And we are currently working towards a settings UI that is coming for a later version of Windows Terminal. And I'll show you a sneak peek of that towards the end of the talk. So I want to customize this experience here. So the first thing I want to do is add an acrylic background. So you can see here the schema is coming into play. That is from VS Code rendering that schema. And if I start typing for acrylic, I'll find use acrylic, and I can set this to true, and this will add an acrylic background to my terminal. I can also change the opacity so it's not as transparent to 0.8, and now it's a little more opaque. I also made a color scheme for build to go with my background, and this one is called build. So it goes really well with this desktop background here. And then what other things do I want to do? I want to also add a background image. So I can do that with just background image. And then I've actually stored this in my OneDrive. And this is so whenever I'm transporting around this settings.json file, all of the image links are the same. So I don't have to worry about changing all the links and where everything is because it's all stored in my OneDrive. So if I set this to a GIF, the Windows terminal does support GIFs and images in the background. This is a community contributed feature. So this is really exciting when we saw that on GitHub and we had to include it in Windows Terminal. And then I can also shrink this down because you can see it's pretty stretched out, and that's with background image stretch mode. And I'll set that to none. And then last is background image alignment, and I want to put it in the bottom right. So that's how I can customize a profile fairly easily using the JSON schema. So some other features that are included in Windows Terminal is our nice search feature. So if I just get some text on the screen by typing ls in PowerShell 7, and then I do Control-Shift-F, you'll see this search window here, and then I can search for my last name, and then it'll go through the instances where my last name appears in the text buffer. So this is really handy if you are looking for a certain command that you ran, or if you're looking for a certain file or folder. This is really handy for finding what you need quickly. Another feature that was contributed by a community member that I want to show you is a retro command prompt. So this is Windows PowerShell using this retro terminal effect, which is set here at experimental retro terminal effect. And what it does, it will add glowing effects to your text, and it will also add scan lines. So if you want to have that classic CRT experience, you can turn this feature on. And we also thought when we saw it on GitHub, we had to have it in terminal. So that's why we added that one as well. So one great thing that Windows Terminal does is that it will automatically detect both Windows Subsystem for Linux distributions as well as PowerShell versions that you have on your machine and create profiles for you. So that's how I got these 4 WSL distros in here. The terminal automatically detected them for me and added them here towards the bottom of my profiles object in my settings file. If you have a lot of Linux distros or PowerShell versions like I do, and you want to hide them from your dropdown, you can set this value hidden to true. So I actually have another version of Ubuntu here, and to demonstrate how this works, if I set hidden to false, it should appear in my dropdown menu. So here I have Ubuntu. So this is very helpful if you're trying to clean up your dropdown menu and you're only working with certain shells at certain times for different projects. You can customize the dropdown menu that way. But if you're looking at these and you're like, okay, well, that's great. I have a lot of profiles, but now I have to customize each one by hand. Well, you don't have to go in to each one by hand if you want the same setting to apply to all of them. So here at the top of this profiles object, I have defaults, and this is where I can put any setting that I want to apply to all of my profiles. So for example, if I wanted my cursor shape to be the filled box, I like to do this for demos because it's easier to see the cursor. Now the cursor shape on all of my shells will be a filled box. So this is one way to customize all of your profiles at once if you don't want to go in to each one by hand. So if I scroll towards the bottom of my file, you'll see all of my color schemes here. This is that build color scheme that I'm using here on the left. And if you are using VS Code, the schema will recognize that this is a hex color code, and you can use a color picker inside VS Code to customize your color scheme. So this is really handy if you are trying to create new color schemes for your terminal. So if I scroll all the way past my schemes, I am a big fan of color schemes. I will find these key bindings here at the bottom. So this is how you can interact with the terminal using the keyboard. So before I dive into the ones that I have here, I want to show you the ones that come already shipped in box. So if you go back to the drop-down menu and you hold Alt and click Settings, it will open the defaults.json file. And this is where all of the default settings are in Windows Terminal. You can't edit this file. So if you want to make any changes, you can do that in your settings.json file. But it's a little overwhelming at first because there's a lot going on, but there's some comments to kind of explain where things are and how things are operating. So if I go here at the bottom, this is where all of the key bindings are. So if you're curious how to interact with the terminal without making key bindings on your own, you can look here in this defaults.json file. But I want to actually use some key bindings to make some panes. So one great thing about Windows Terminal is that you can have different panes inside of different tabs running different shells. So here in my key bindings, I have a split pane command down here, and this will auto split my window, which will give me the largest surface area for a pane. And then it's also set to split mode duplicate. So this will duplicate the focus pane into a new pane. And I can do that by typing Alt-Shift-D. So if I did Alt-Shift-D, I'll get a duplicate of my PowerShell 7 profile in 3 different panes. And I can close them by typing Control-Shift and W. So if I wanted to create a new key binding that will give me a new profile with a split pane, I can start by typing Command and do action, the same as split pane above. And then I'll also have that split auto. And then I will specify profile with the profile name. So I want to open a Ubuntu 2004 profile. And then the keys I want to have for that are, let's see, Control, Shift, and U. U for Ubuntu. So then if I come back in here and type Control, Shift, U, I'll get a new Ubuntu profile. And I can type Control Shift U again and get another split of that. If I went back up here and did Alt Shift D, I'll get the duplicate of that. So you can get really creative with your custom panes here in the terminal. But if you wanted to launch terminal in a specific configuration, instead of having to create all these key bindings, you can come in and use Commandline Arguments. So if I go into command prompt and type something like WT-D. Oh, wait, actually, let me back up. Let me go into my desktop folder so you know I'm in a different folder. If I did WT-D dot, this will open a new terminal instance with my default profile in the current working directory. So if I hit enter, I get Windows Terminal in the desktop directory. So you can get a little more creative with this and do something like WT-D dot. So the same, but then I want to split a pane with my Ubuntu 2004 profile in a horizontal pane. If I hit enter, I should get the same layout that I just had on the previous tab. So if you don't want to create those key bindings, you can use Commandline Arguments to get a custom configuration right on launch. And what's great about this is you can create shortcuts and save them to your desktop or even your taskbar. So I have one down here. If I run it, I have another configuration of different split panes with different profiles. So you can get really creative with these arguments as well. So that's all I have to show you for Windows Terminal 1.0. These are all features you can get today. So I'm going to hop back into the slides and show you things that are coming next. So what's coming next for Windows Terminal? Well, right now we do have 2 different release channels that you can join. The first is the Windows Terminal stable channel. This is for everyone who wanted to use Windows Terminal, but they needed something that wasn't in preview. This is the build for you. This will have monthly releases, and the first scheduled update is for July 2020. So we will have updates coming very soon. And you can get this build from aka.ms/terminal. But if you're someone who wants the newest features right away, you want to help contribute on GitHub, you want to test all the latest stuff, you can get on the preview channel at Windows Terminal Preview, and you can find that on the Microsoft Store at aka.ms/terminal-preview. And this will also have monthly releases, but the first release is scheduled for June 2020. So the features that are developed in the preview branch then move into the stable branch after they've been stabilized. So I'm going to show you some sneak peeks of things that you'll be able to find on the master branch of GitHub or even in the preview in June in that release. So I'm going to hop back to my demo machine and show you some new features. So I'm going to actually run the build that I made on my Surface Book 3 of Windows Terminal from the master branch on GitHub. So if I go to my dev build, this is the build I made from GitHub. So I haven't done really any customization. So you can see that Powerline font isn't even set. I just made it straight from the branch. So some new features you can find in the June 2020 release of the preview is one of them is tab color picker. So you can right click on a tab and hit color, and then you can get this nice color picker and choose a new color for your tab. Or if you want to get a little more specific, you can hit custom and use this color picker, or even use the hex code here or the RGB values here. So I do like this feature the best because then you can match your background to your tab color. So this was contributed by a community member, and we wanted to have this as one of the first things in the Windows Terminal preview coming in June. Another feature we have coming is rename tabs. So if you have a bunch of tabs open and maybe they're all Ubuntu's or they're all PowerShells, you can right click and say rename tab and then type whatever you'd like into the tab and then save it, and you'll have a new tab title. So this is stuff that's coming in June for the Windows Terminal preview, and then it'll move into the stable Windows Terminal branch in July. And another thing I want to show you, this is very sneak peek. This is not coming in June. This is coming in a little bit, is the settings UI work we've been doing. So we've been trying to develop the settings UI, and here we have an application of the direction it's heading. So this is our globals page, and we have some profiles as well as color schemes. So we wanted to demonstrate this, that it's in the works, and we're trying to make sure that you have a settings UI as soon as possible. So if you want to contribute to this, it is on GitHub, so you can go and find that and share your thoughts on the design, and then maybe also help with some development if you're interested. So this is some new features that are coming for the Windows Terminal preview and also future versions after that. So if you want to stay up to date with what's new with Windows Terminal, you can follow me on Twitter at cinnamon_MSFT. I tweet about all the new stuff with Windows Terminal all the time. If you want to contribute on GitHub, if you find any bugs, if you want to file any feature requests, if you want to write code, you can find the GitHub at github.com/Microsoft/terminal. I also write a blog post for every release that we have, and you can read all of those at aka.ms/CLI blog. And then, of course, install the Windows Terminal and the Windows Terminal preview from aka.ms/terminal, as well as /terminal-preview. And then once you've downloaded the Windows Terminal and you want to start playing with it, please go to our documentation site where you can find all of the answers to all of your questions at aka.ms/terminal-docs. So now I'm going to pass it off to Craig, who will talk about what's new with WSL.
Thanks, Kayla. So let's talk about the Windows Subsystem for Linux, or WSL. Just to level set, WSL allows you to run all of your favorite Linux command line tools, utilities, and applications unmodified and directly on Windows. What really sets WSL apart from a traditional Linux experience like a traditional VM or dual booting is that you're able to access all of your Windows files directly from the Linux environment, as well as run Windows executables straight from your bash shell or any other shell that you might be using, as well as you can go the other way. You can access Linux files from Windows, and you can invoke Linux binaries from Windows as well. And so the direction that we're going is we're really trying to integrate as much as we can Linux workflows and Windows workflows together, so you can feel like it's all on the same machine. And a customer who's really used this well is EA, or Electronic Arts. And so they were developing an engine for a video game called the Frostbite engine. And if you haven't heard of it, you've probably played on it. They use it for Battlefield 5, as well as Star Wars Battlefront 2, personal favorite of mine, and Madden and FIFA. And this engine required a Linux component to it. They needed to have Linux inside of servers online to facilitate network connections between players. And the problem that they had was they had an entirely Windows shop with a bunch of developers who are used to developing on Windows machines. And so when they initially set up a cross-compilation environment, they had completely orthogonal Linux machines that had some esoteric scripts on them to facilitate cross-compilation and remote debugging. And when they found that Visual Studio supported the Windows Subsystem for Linux, they were able to really easily port all of their workflow over to use WSL. So instead of having these random offset of machines to support that, they were able to use their exact development machines. They were able to use Visual Studio and debug directly in the Linux environment, all without having to figure out anything new involving Linux, and they were still able to use their Linux tools and workflows while maintaining their Windows machine. So it's great for developers because they were able to access Linux tools. And it's also awesome for the IT pros and administrators because they can help manage the Windows machines, and they don't have to worry about setting off this random offshoot of Linux machines. And we want to continue improving WSL. And the latest improvement is the Windows Subsystem for Linux 2. This is a new architecture behind WSL. and it allows you to run exactly the same things, Linux binaries. The user experience is exactly the same. We've only changed everything behind the scenes. And there are some significant benefits here. We've included a real Linux kernel inside that's built by Microsoft, and that gives 100% system call compatibility. As well, we've moved from a translation-based approach where everything ran under the Windows NT kernel to a virtualization-based approach. So now everything is running inside of a lightweight virtual machine that you don't really have to think about or manage because we manage it totally for you. And this brings some significant file I/O performance improvements as well. And so the actual details of the file I/O performance is you can get up to 3 to 6 times faster using the Windows Subsystem for Linux 2. So on the slide, I have a comparison between WSL2, which is on the left, and WSL1, which is on the right. And in WSL2, installing Python took 14 seconds, and in WSL1, that took 90 seconds, which is a 6 times difference. This is something that you're going to notice for sure, because what's the first thing you do when you run your distros? You do a lot of sudo apt update and sudo apt install, which you'll see there. As well, you'll notice it when doing things like git clone or npm install. And in fact, for really file I/O heavy operations like extracting a tar file, we've seen it go up to about 20 times faster, which is really an incredible difference. The other half of the story is the file system, is the 100% system call compatibility. And the great thing about this is a lot of the apps that you're already used to using will now work better because all of their system calls are fully supported. But the even better part of the story is that you can now use more Linux apps inside of WSL. This includes Docker. So you can now run Docker containers directly inside of the Windows Subsystem for Linux, which means you can use containers inside of your Linux workflows. And we aren't the only ones who are excited for this. Docker Desktop has actually made some changes involving this as well. So Docker Desktop has released a new version of their Docker Desktop client that has an option to include the Windows Subsystem for Linux inside of it. And so all you're going to need to do is click on Preferences, Settings, and then check Enable the Windows Subsystem for Linux Experimental Engine. And from there, all of your Linux containers will run inside of WSL2. Why this is awesome is because you will get significant improvements to your CPU and memory usage, as well as the startup time will go from about a minute to the order of seconds, which is pretty awesome improvement. We're also improving integration between WSL and Windows in other ways, and that includes VS Code Remote. So VS Code Remote allows you to run and debug and build all of your Linux applications in a fully fledged Linux environment entirely in VS Code using WSL. So the only thing that runs in Windows is the UI. Everything else, accessing your files, running your debugger, building your scripts, etc., all happen inside of Linux. So now you can use that Linux IDE, develop directly and quickly, as well as using containers all within WSL. And so this is available now in the Windows 10 May 2020 update, and you can start using it right away. And so that's the stuff that's available now, and we'll move on to what's going to be coming up next, and what can you expect to see in the future with WSL. And the first thing that I want to touch on is we are improving the integration more between Windows and Linux. And the first part that we're doing for that is File Explorer integration. So this is a screenshot of the Windows File Explorer. And you can see that we've added a familiar face. Tux, the penguin, is there with Linux beside him. And this is a Linux option that you can click on. And when you click or expand it, you'll see all of your Windows Subsystem for Linux distributions there. So there I have Debian and Ubuntu. And you can click through these folders and access all of your Linux files straight from Windows, which is pretty amazing. On top of this, we're also improving the install experience for WSL as a whole. So on any Windows machine, you can run WSL space -- install, and this will enable all of the required optional components for you. And after a quick restart, it will install your specified distro. So I have a video demo of what this looks like so that we can speed through the bits. And let's take a look. So this is the demo of WSL -- install. You can see I've opened up an administrator window running PowerShell in this case. I've typed in WSL space -- install on this fresh machine. It enables all the optional components and it tells me I need to restart. So we've actually skipped ahead of and sped up this process of restarting the machine. It installs the required features, and then upon restart, it will show a window installing the distribution that you specified. So here in this case, I'm installing Ubuntu. And once this is done installing, I'll see the username creation and password creation screen. And then after that, I'm done and ready to go. So for this next announce, I'd like to ask you, what is WSL's #1 most requested feature? And if you guessed GPU compute, you would be correct. We're really excited to announce that GPU compute support is coming to the Windows subsystem for Linux. And so for some of you, that really might be exciting. But for others of you who might not have had much experience with what GPU compute can do, it might not be as obvious the benefits that this brings. So I wanted to jump into a quick explanation of what exactly this means. So at its base level, GPU compute enables parallel computing. So that means that you can run a bunch of math operations together at the same time, way faster on a GPU than you could on a CPU. So I just have some math on the screen. Don't worry, we're not going to actually do math. And I just have matrix multiplication between two matrices. And the fun fact about this is each cell of the matrix is independent of each other. And so this is a great application for a GPU. And where that gets used is for things like machine learning and AI development. And so on the screen here, I have an example of a filter being applied to an image. And at the end of the day, that's just matrix math. And this goes exponentially faster using a GPU than a CPU. And really, this builds on more complicated machine learning and AI models. For example, here I have a model where a user inputs a number, so the letter 2 at the bottom, they draw it, and then the AI, in this case a neural network, understands what they wrote and synthesizes that into an output. And so it can accurately detect what letter, or in this case, number, the user wrote, which is pretty amazing. And even more, building on this, we can take a look into the future of machine learning and AI and where innovation is happening right now. This is a screenshot from an example from NVIDIA of their DriveNet demo. And it shows a camera mounted on a car, and an advanced neural network is determining where people are, where signs are, and where other cars are to help build self-driving cars. So now with WSL, it's possible to actually build and train these models and run them because you can leverage the GPU. So what did we actually change to make this possible? Well, to explain that fully, I just want to give a really quick high-level overview of what it means to actually train a machine learning model. All you need is training data. So this is just marked data of, hey, this is a person, this is an image of a car. You feed that into a machine learning algorithm that you develop, and then eventually it will output a trained model that can accurately detect people in cars, for example. And if we expand this middle section, you can see that that machine learning algorithm actually depends on a machine learning framework. So you build your algorithm using a common framework. And so if we expand the stack of what this framework relies on, we can see the changes that we made. So the framework that you're using could be things like TensorFlow or PyTorch, and then those call into a hardware acceleration API. And that it could be CUDA or DirectML. And those hardware acceleration APIs call into your GPU itself, which is the GPU on your machine. Next slide, Kayla. Thank you. And so what we've done is in the stack is we've changed this middle bit here, the hardware acceleration API layer. We have partnered with hardware vendors like NVIDIA, AMD, and Intel, and they've provided drivers that are aware of the Windows subsystem for Linux. And we've also made changes internally in WSL to make this possible, and to the Linux kernel itself that we build as part of our releases for WSL. And at the end of the day, this makes it so that any system calls from Linux binaries happening inside of your WSL instance are aware of the GPU and are able to send computations to it using this hardware acceleration API, be it CUDA or DirectML. So I have a quick demo of what that looks like on my machine. Let's take a look. So here I am on my demo machine, and I'm just navigated to a folder with SqueezeNet inside of it. SqueezeNet is just a popular image recognition neural network. And I can run Python and train to.py. From here, it's going to start up TensorFlow, and we are going to start seeing hits on our GPU because we're going to start doing work on side of our graphical processing unit. And so what it's doing right now is spinning up TensorFlow, getting the required Python libraries. And then once it starts up, we're going to start the training process. And so we're actually going to start training this model on different images. So we're going to load in different images into memory. We're going to show it to the machine learning model, and then it's going to start extensive training over many, many generations. And eventually, after many hours of training, it will have an outputted model that can accurately detect different images. All right, so now the actual model has started up. We've loaded TensorFlow, and then we can start the training process. So you're going to start seeing generational outputs and the accuracy of the outputs beside it. And once this starts happening, you'll see our GPU use will spike dramatically. And there we go. So we're at training step 403 because I ran this model before we started. And you can see that the GPU here has spiked, and we're at 95% usage. So we're actually leveraging our GPU to do this. And this is really awesome because I'm doing this all on Windows machine. However, I'm using Linux tools, Linux binaries, and Linux workflows to accomplish this. And this GPU access is also being shared with my Windows machine on itself. So I'm rendering my desktop, but I don't have to worry about dedicating this GPU entirely over to this machine learning process. So overall, it's a change that is super highly requested from you, the community, and we're really excited to see what you can start doing with it. So let's jump back to the slides. And if you were really sharp-eyed in that demo, you would have noticed that I ran it on an AMD graphics card. And the really exciting part about this is you can run these workflows across different GPU vendors. So this supports CUDA, which is a industry standard and very popular hardware acceleration API layer that's really commonly used by industry professionals everywhere. But we also support DirectML. This is awesome if you're a student or jumping into machine learning and you want to try it out and maybe you don't have an NVIDIA graphics card directly, because this works with any DirectX 12 GPU. So that demo, I actually ran that on a Surface Laptop 3 to train that AI model, which is also really exciting because it makes it really accessible. No matter what configuration you have on your machine, you can still run Linux workflows, any Linux app using GPU compute. And so the instructions for this are all you need to do is make sure you have the Windows Subsystem for Linux installed. Make sure you install the right driver for your GPU. So this will be directly from the hardware vendor's site. And once you have those installed, you are ready to go. You can start running your Linux machine learning workflows directly inside of WSL right away. And so this leads us to our roadmap of what you can expect to see from WSL in the future. The Windows 10 May Update 2020 has the Windows Subsystem Linux for 2 in it, which is available now. From there, if you're on the Windows Insider's fast ring, you have access to File Explorer integration right away. And in the next few months, you're going to see WSL -install to allow 1 command line installations. And you're also going to see GPU compute in the Windows Subsystem for Linux as well in the next few months. And of course, there's one extra thing we have to talk about. We are adding GUI Application Support in the Windows Subsystem for Linux. This means you'll be able to run your favorite Linux applications directly on Windows. And so this is a bit farther out than WSL-install or GPU compute. But we wanted to talk about it because we are working on it internally, and we wanted to share our progress and our long-term goals with the community. So we'll jump on over to my machine because I cannot mention that without showing you an early demo of what it looks like. So I'm back on my machine, and I've opened up 2 terminal windows. And on this one on the left, you can see the output of running our Wayland compositor, because what we're actually doing is running a Wayland server inside of Linux and connecting this to an RDP client on Windows on the host machine. So let's take it for a spin. I have a media folder in here, and I'm going to run Eye of GNOME, which is EOG, and I'm going to show a diagram of maybe a machine learning project that I'm working on. So in the case of this example, I am running Space Invaders, and I'm making a machine learning model that learns how to play Space Invaders. So we'll zoom in so that we can see the details on this Linux app. And you can see that it's a full Linux app. I can go and zoom in and drag around. I can access file context menus, and I even have the Linux decorations on top. Of course, you're going to see some critical messages on the side because, as I mentioned before, this is an early build. However, this is a fully fledged running Linux app running directly on Windows. So I'm going to close this out, and we can look at some other examples. I'm going to restart this server. And from here, I'm going to go 1 folder up, and then I can actually open up different files that I have here. So I can run gedit and then run play.py. And this will open up the script that I use if I wanted to play that Space Invaders game to try it out. And what's really cool about this is I'm opening it up in gedit, a common Linux editor. And the really exciting part about this is when I open my files, these are all running inside of a Linux context. So I can open up my .bashrc file as well and access all of these files from my Linux environment, all in a Linux way. So this is similar to VS Code Remote, where you can have Linux IDEs and Linux-based build scripts and tools and debuggers. You can run these now directly from WSL as well, which is really powerful for eventually using things like IntelliJ-based editors like IDEA or PyCharm. And so let's close this down and let's do one more demo of what this looks like. I'm going to really put it through its paces, and I'm going to run a video of someone playing Space Invaders that could be part of maybe my markdown file from my repo. So here you can see the demo of we're actually running video using this. It's running straight from Linux. You can see the output here in the terminal, and I can scrub through this video. It's actually really performant, which is awesome, and overall a really exciting change. So that's an exciting sneak peek at something that we're working on that will be coming out in the future. If you want to learn more about GUI apps, GPU compute, WSL dash install, or really anything else that I talked about here, here are some awesome ways that you can stay involved. If you go on Twitter, you can follow me at Craig A. Lowen. I talk about WSL there all the time. As well, if you want to learn news about releases and details and fully fledged blog posts about any WSL announcements, you can check out the Commandline blog at aka.ms/CLI blog. If you want to file issues or see other technical problems that people are running into with WSL, you can go to our GitHub page at github.com/Microsoft/WSL. And lastly, if you want to know everything and anything about the Windows Subsystem for Linux, please check out the docs at aka.ms/WSL docs. Thank you so much for joining us today. We are really happy that you could take the time to learn more about the new Windows command line. And thank you so much. Is there anything else you wanted to add, Kayla?
Nope. Just make sure to stay safe out there.
That sounds great. See ya. Goodbye. Thank you.
Bye.